Hello everyone. In this video, I will talk about solutions to 2021 AMC10A. Let's start from question 1. So we evaluate the following expression. Let's do direct calculation. 2 squared minus 2, that equals 4 minus 2. 3 squared minus 3, that's 9 minus 3. 4 squared minus 4, 16 minus 4. This equals 2 minus 6 plus 12, which equals 8. So the answer is 8. Question 2. Portia's High School has 3 times as many students as Laura's High School, P, L. So in P High School, we have 3. The number of people is 3 to 1. So let's see, we have 3x here, 1x here. So now we have total students. Total students is 2,600. So the student in Portia's High School, that will be 2,600 times 3 over 4. That gives 1,950. So the answer here is C. Question 3. The sum of two natural numbers is given here. One of these two numbers is divisible by 10. Suppose this number, let me denote by 10a. Now, the unit digits of this number is erased, and this gives the other number. That means the other number is this number divided by 10, because we just erased the unit digit, which is 0. So the other number is 10. The other number is just a. The sum is given. And the question is, what's the difference of these two numbers? So the difference is 10a minus a, which is 9a. Okay, from above, we have 11a is given. So here we want 9a. So basically, we have the number equals 9 over 11 times 17402. This equals 14238. The answer here is D. Question 4. A cart rolls down a hill traveling 5 inches in the first second. And in the future seconds, during each successive 1 second time interval, it travels 7 inches more than during the previous 1 second interval. So totally it travels 30 seconds. So we need to calculate the total distance. So in the first second, the distance is 5. In the second second, the distance is 5 plus 7. In the third second, this is 5 plus 7 and plus 7. So 5 plus 2 times 7. So we have the last interval, the last second is 5 plus 29 times 7. So let's calculate the sum. So in each part we have 5. So let's do 5 times 30. And for the multiples of 7, let's say it's 7 times 1 plus 2 plus 3 up to 29. So this 150 plus 7 times the summation formula applied to this summation from 1 to 29. This 1 plus 29 times 29 divided by 2. So 150 times 7 times 30 divided by 2, 15 times 29. So this gives the answer D, 3,195. The answer is D here. Question 5. The quiz scores for a class with K students have a mean of 8. And the mean of a collection of 12 scores is 14. What's the mean of the remaining quiz score in terms of K? So totally we have K quiz scores. It's divided into 2 groups. In one group we have 12 scores. In the other group we should have K minus 12 scores. Now the total for the overall average, the number is 8. And for the collection 12 scores, the average is 14. We know the total score can be calculated in two ways. Suppose the average for k minus 12 is x, the average, or mean. The total score equals 8k on one hand. On the other hand, it equals 12 times 14 plus k minus 12 times x. So from here, we can solve x. And 12 times 14 equals 168. So we have x equals 8k minus 168 divided by k minus 12. The answer here should be B. Question 6. Chantal and Jing start hiking from a trailhead towards a Phi Tower, and Jing walks slower, Chantal faster, and halfway the tower, the chair becomes really steep, and the Chantal slows down to 2 miles per hour. Before that, her speed was 4 miles per hour. So basically, let's draw a picture. Suppose this is the trailhead. For the first half of the chair, it is good. After that, it becomes steep, very steep. So let's do this way. So this is a trailhead. And this is a fire tower. So this flat piece and the steep piece, they have the same distance. Okay, so this is the mid mark. Okay, the halfway point. Halfway point. Now, Chantal walks faster. In the first half, she walks the distance is 4 miles per hour, and then she walks, say, 2 miles per hour up to the fire tower. And then she turns around, and the distance back to Jean along the steep part. So she goes down here. So the speed was 3 miles per hour. At this halfway point, they meet. So that means Jean only walked half the chair. This is Jean. Okay, this one's Chantal. Now let's calculate the average speed of Jean's average speed. So let's just assume the half distance is, say, s. So total distance twice s. Now the time, we calculate the time by Chantal's work. So for the first s, Chantal speed was 4. For the second s, Chantal's speed was 2. For the third part, Chantal's speed was 3. That's the total time. And this corresponds to 13 over 12s. That's the total time. And for Jean, her distance was just s. So the velocity of Jean is the distance divided by time, which gives you 12 over 13. That's her speed. So the answer here is A. Question 7. Tom has a collection of 13 snakes. 4 of them are purple and 5 of them are happy. Some can add, some can subtract. So let me use this circle to denote the set of snakes. The first circle is happy snakes. Okay, and the statement says that all his happy snakes can add. That means the snakes can add is a larger group. So I draw a larger circle here. So this is all snakes can add. Okay, we look at the third statement here. All his snakes that cannot subtract also cannot add. That means if a snake can add, the snake must be able to subtract. That's equivalent statement. That means the snakes can subtract is a larger group than the snake can add. So this group all snakes can subtract. And then we look at the second statement. None of his purple snakes can subtract. So the snakes can purple snakes should be not included in this group. So this group is some snakes can purple snakes, because none of his purple snake can subtract. Now let's check those statements. So first statement, purple snakes can add. That's wrong, because from the picture it's clear, right? It's wrong. Purple snake cannot add. And purple snakes are happy, and that's wrong. Happy snake must be able to subtract, but purple snake cannot subtract. So purple snake are not happy snakes. Snakes that can add are purple. That's also not correct. Happy snakes are not purple. That's true. And the happy snake cannot subtract. Happy snake can subtract because happy snake is a subset of snake can add. Snake can add is subset of snake can subtract. So this is wrong. So our answer here is D. Question 8. Students multiply number 66 by the repeating decimal, but he did not notice the notation, repeating notation. He just multiplied 66 by 1.AB. But actually, the correct calculation should be 66 times 1.AB repeating. And his wrong answer is 0.5 less than the correct answer. So we have the following relation. The left-hand side plus 0.5 equals the right answer on the right. That's the relation. And now we can have the following. So 0.5 equals 66 times 1.AB repeating minus 1.AB no repeating. And this actually equals 66 times point. We cancel the 1 and the first A, first B. So this is 0.00 and the repeating part from here, AB, AB, dot, dot, dot to infinity, right? And let's try to solve AB from the equation here. This is 1/2 on the left. Now, this is equivalent to 1/2 equals 66 times. Let me shift the decimal places by decimal point by 2 places. So 1 over 100 times point AB, 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 dot, dot, dot. Now let's write this term in terms of fraction. We have standard formula to do that. So let's say x equals point AB, AB. So we multiply this by 100. 100x equals AB, point AB, AB, repeating. And we do subtraction. 2 minus 1 implies 99x equals AB. That means AB equals, here AB is a 2-digit number. It's a 2-digit number. Okay, it's not multiplication. So let's avoid this confusion. So AB equals okay, 99x equals AB. So we can solve x in terms of AB. X equals AB. This is a 2-digit number over 99. Okay, over 99. So here we have the equation 1/2 equals 66 times 1 over 100 times this x. X is already in fraction. This AB over 99. From here, we can solve AB equals 75. So the answer here is 75. Question 9. What's the least possible value of this expression in terms of x and y for all real numbers x and y? Let's open this square and try to simplify it. So xy minus 1 square plus x plus y square. Let's open the first square. This becomes x squared y squared minus 2xy plus 1. And the second square gives x squared plus 2xy plus y squared. Now we can basically cancel this 2xy. One is positive, one is negative. Finally, we get the following. This equals x squared y squared plus x squared plus y squared plus 1. So the first three terms, they are all square terms, so they must be non-negative. And we have constant 1, so this obviously largely equal to 1, largely equal to 1. And 1 is actually can be obtained. Inequality can be achieved if we take x equals y equals 0. So the minimum number, the least possible value equals 1. Answer is D. Question 10. So which of the following is equivalent to the following multiplication? Let's check this multiplication. Each the power for 2 or 3 will be doubled in the next parentheses. So here we can use the difference of square formula. Let me denote the value by a. So a equals 1 times a, and 1 equals 3 minus 2. So this becomes 3 minus 2 times 3 square plus 2, 3 plus 2, 3 square plus 2 square, 3 fourths, 2 fourths, 3 eighths, 2 eighths, 3 sixteenths, 2 sixteenths, 3 32s, 2 32s, 3 64, 2 64. Right? Now let's do the first multiplication here. This becomes 3 square minus 2 square by the difference of square formula. And for the other part, we keep the expression here. And the pattern continues. If we do the next multiplication, you will have the following by the difference of square formula, 3 fourths minus 2 fourths. And the other part, the same, 3 fourths plus 2 fourths, 3 eighths plus 2 eighths, 3 16 plus 2 16, 3 32 plus 2 32, and 364 plus 2 64. And keep going. We will keep this pattern and the increased power. Each time we double the power. Next one is 3 eighths minus 2 eighths. Next one is 3 eighths plus 2 eighths. 3 16 plus 2 16. 3 32 plus 2 32. 3 64 plus 2 64. Right? Keep going. This multiplication will have 3 16 minus 2 16. 3 16 plus 2 16. 3 32 plus 2 32. 3 64 plus 2 64. So one more here. We got this is 332 minus 232. 332 plus 232. 364 plus 264. And one more, we get the next term equals 364 minus 264. And the last multiplication here give us the answer is 128 minus 128. So the answer to this problem is C. Question 11. For which of the following integer b is the base b number expressed here not divisible by 3? So let's first simplify the number here. Let me call this number to be a. And we know the last two digits are the same. So basically they cancel each other. So a is basically 2000b minus 200b, because the last digit they cancel, right? And this becomes 2 times b cubed minus 2 times b squared. It's 2b squared, b minus 1. So that's the number a in terms of b. Let's check each term. For the choice a, if b equals 3, that means a equals that is divisible by 3, right? 2 times 3 squared times 2. This is divisible by 3. And for b equals 4, so b minus 1 give us a multiple of 3. So a equals 2 times 4 squared times 3. So this is a multiple of 3. b equals 6. This is also multiple of 3 because we have b squared. And for b equals 7, this is also a multiple of 3 because b minus 1 is 6. 6 is multiple of 3. And only the last term, if b equals 8, this is not divisible by 3. So this is not divisible by 3. So we should choose E, b equals 8. Question 12, we have two right circular cones with vertices facing down as shown in the figure, and they have the same amount of liquid. And the radius for the liquid surface 3 and 6 respectively. Now let's try to find the ratio of their heights. I would denote the first height, say h1, and the second height as h2. Because they have the same volume, let's express the volume. So for the first part, we have the formula 1/3 times pi times radius square and times the height. That's the volume for the first cone. For the first the liquid in the first cone. The other part is 1/3 times pi times 6 square times h2, and they are equal. From here, we can solve the ratio of h1, h2. h1 over h2, we can cancel 1/3 and pi, and so the ratio of 6 squared over 3 squared, that's just 4. 6 squared over 3 squared. This is a 4:1. So the ratio is 4:1. Now we drop a spherical marble of radius 1 to both cone. That means actually we just increase the volume by the same number. What's the ratio of the rise of the liquid level? So if we increase the volume in each of this cone, the shape does not change. The size changes, but the shape does not change. So let's see, we have maybe something slightly larger. Let me draw slightly larger. We can basically have the idea of a similarity, right? This is 3D similarity. The radius, the height, they are scaled by some number. Suppose this is like a new h, and for on the right, we also have a new h. This is new h. Since they have they scale, okay, because new volume is still the same. So for any volume, we have the same shape. They still have the same volume, so the scaling number is still the same. The scaling number is still the same. That means we always have the same ratio. Is still 4:1. That's the ratio for new H. Okay, and of course here we look for the ratio for the rise. We look for the rise is capital H1 minus little h1, 2 capital H2 minus little h2, because h1 little h1 to little h2 is still 4:1, so the difference also 4:1. The ratio is always 4:1. The answer is E. Question 13, we have a tetrahedron ABCD with edge length given. Now let's find the volume. So here I draw the tetrahedron here. Suppose it's A, this is B, this is C, this is D. So AB equals 2, and AC equals 3, AD equals 4, BC equals root 13, BD equals 2 root 5, and CD equals 5. We will see there are right angles, because 2 square plus 3 square equals root 13 square. That means angle BAC is 90 degree. And 3 square plus 4 square equals 5 square. That means angle CAD is 90 degree. And 2 square plus 4 square equals 2 root 5 square. That means angle BAD is 90 degree. So we can calculate this tetrahedron as follows. So it's 1/3 base area times the height. We can take a CAD as the base. Triangle ACD, that's the base. And the height is basically AB because it's perpendicular. AB is perpendicular to AD, perpendicular to AC. Let me write down AB perpendicular to AD, AB perpendicular to AC. That means AB perpendicular to the plane, ACD. So that's the height. And we can plug in the number to solve the volume. 1/3. The area of ACD is basically 1/2. It's a right triangle, so it's 1/2, 3 times 4. The height is 2. So we have answer equals 4. The volume here is 4, which is C. Question 14, we have the polynomial of degree 6. All roots are positive integers, possibly repeated. What's the value of B, the coefficient for cubic term? Now, we have 6 roots. Degree 6 polynomial has 6 roots. And here they are all positive integers. So we can write the following. The polynomial can be factored into z minus z1, z minus d2, z minus d3, z minus d4, z minus d5, z minus z6. So basically we use the Vieta's formula. So the product of the roots is 16. z1, z2, z3, z4, z5, z6. The product equals 16, and 16 equals 2 to the 4th power. And we also know the degree 5 term, the coefficient is -10, so we have the sum of the roots by Vieta's formula. equals 10. Okay, negative b over a here. Negative b is negative 10, a is 1. Now we have this information, and they are all positive integers. That implies the values of these roots. So you can basically check. You will see this equals 2 times 2 times 2 times 2, and we have 6 terms. So the other one, let's choose 1, and that gives the sum equals 10. This is 2 plus 2 plus 2 plus 2 plus 1 plus 1. So we must split this 2 to each term. If we have 4 or 8, you will see that doesn't work. It cannot give you the sum equals 10. So this is not hard to see. So right, we have the roots the roots are 2, 2, 2, 2, 1, and 1. Now let's find what is b. B is the coefficient for a cubic term. So we have b equals the collection of or product of 3 roots, and we have a negative sign. So b equals, say for example, z1, z2, z3, say z1, z2, z4, all possible combination of 3 terms product, z4, z5, z6. If you write in a notation, that means summation, like zi, zj, zk, and ijk are different. They are different, okay? That's the variable b. So let's see how many product here. We have totally 6 choose 3. 6 choose 3, that we have 20 terms. But here we have the roots are repeated. So we have 4 2's and 2 1's, and they are basically few category. So for 3 terms, we have 3 cases. First, all these 3 terms are 2. Say 2 times 2 times 2. For such a kind of combination, let's see how many terms give this combination. So the product equals 8, right? And how many such kind of combination? We choose 2. So we choose 3 twos from 4 twos. There are 4 ways to choose 3 twos. Each product gives us 2 cubed. So this is the value. 4 times 8, which is 32. And the second type of combination, these 3 roots, they are 2, 2, 1, 2, 2, 1. To choose 2 twos, we have 4 choose 2, and choose 1, 1, that's 2 choose 1. The product has value 4. So this is 6 times 2 times 4, 48. And the third case, we have only 1, 2. The other roots are 1 and 1. Now we choose a 2 from 4, 2. 4 choose 1. And a 2, we only have 2 ones. So 2 choose 2. That's only way to do that. And each product has value 2. So it's 4 times 2, which is 8. And we cannot have 3 ones because we only have 2 ones. So these are 3 all cases. Now we get a summation equals 32 plus 48 plus 8, which is 88. That means the summation of this product equals 88. This equals 88. So B equals negative 88. Right, that's this answer is A, negative 88. Question 15. Values for A, B, C, D are to be selected from number from 1 to 6 without replacement, so they are distinct. How many ways are there to make the choice is that 2 curves intersect. These 2 curves intersect means the solution exists for the equation here. Ax squared plus b equals cx squared plus d. We can solve x from this equation. Now let's move x squared on one side. This means a minus c x squared equals d minus b. That solves x squared equals d minus b over a minus c. A minus c. This has solution, and there's no they are distinct, so this must be positive. So that means we only require D minus B and A minus C, they have the same sign, both positive or both negative. Right, we have basically two cases. So first case is say A larger than C. So in denominator is positive. So the numerator must also be positive. So B less than D. The second case is A less than C and B larger than D. So here in this problem, it says that the order of the curve does not matter. The order does not matter. So this 1 and 2, actually, they are equivalent. They are considered as the same choice, because we can just switch the row of AC, switch the row of BD. They are equivalent. So we only consider 1. Now let's see how many ways can we choose A, B, C, D to satisfy this condition. First, we know that we choose 4 numbers. So 2 numbers not selected. Or we just choose 4 number. Well, I can do, we choose 4 numbers. That means we have 6 choose 4. That's equivalent to not choose 2 numbers, 6 choose 2, which is 15. We have 15 ways to choose 4 numbers. They are distinct numbers. And next, okay, let's see, we have 4 numbers. Let's see, let's just say 1, 2, 3, 4. Now let's determine A and C. Determine A and C. That means we just choose 2 numbers from those 4 numbers. 4 choose 2. The larger number goes to A, the smaller number goes to C. So there are 6 ways to choose it. And for the remaining 2 numbers, the larger number goes to D, the smaller number goes to B. So our answer should be 15 times 6, which is 90. Okay, the answer is C here. Question 16, in the following list of numbers, each integer n appears n times, from n from 1 to 200. What's the median of the number in the list? That means what's the number in the middle places? Of course, we have so many numbers. Let's count total number of numbers. Total number of numbers. That's 1 plus 2 plus 3 plus 200. This corresponds to 200 times 201 divided by 2. This is 201. 100. This is an even number. So we need to find the middle 2 numbers, and their average should be the median. So the middle place, on the left we have half, on the right we have half numbers. So we find a half to so 2000 2100 200 100, and this divided by 2. This is 10050. So we need to find, suppose the median is n. That means if we add 1 to 2, 3 up to n, this should be larger, equal to this number. Say, let me draw a picture. 1, 2, 2, 3, 3, 3. So n minus 1, n minus 1, n minus 1. Now suppose the median is n. The median is n. That means the middle place, suppose the middle place is here. So that means we count all numbers up to n minus 1 and some numbers of n. Some numbers of n. That means we have the following. If we add all numbers from 1 to n minus 1, n minus 1. This equals n times n minus 1 divided by 2. This should be less than this number. If we add all numbers, less equal to, or maybe this red line is at the boundary of n minus 1 n. That's possible. So if we add all numbers up to n, this is n times n plus 1 over 2. This should be larger equal to 10050. So let's find the requirement for n. This is first requirement. And the second requirement is n times n plus 1 larger equal to 20100. Let's find such n. So 200. So n times n minus 1 or n times n plus 1 is very close to n squared. Let's try to estimate the square root of this number. So it's easy to see that 14 square. Know that 14 square is 196. So we get 140 square is 19600. This is quite close to 201 100. So the number should be approximately 140 something, close to that number. So we can basically check some numbers. First, we know that 141 times 142, this is 20022. This is smaller. And 142 times 143 equals 20306. So the first number is less than 20100. The second number is larger than 20100. So from here, we can see the number n should be 142. Should be 142. So the answer here is 142, which you see here. Question 16, we have a trapezoid ABCD. Satisfying BC equals CD 43. So let me draw the picture here. This is D, C, B, A. BC equals 43, CD equals 43, and the AD is perpendicular to BD. Now, the intersection of diagonal is O. And the P is the midpoint of BD. So if I connect C and P, it's perpendicular. Now, let's see, given that OP equals 12, and we try to find the length of AD. So because DC equals BC, triangle CBD is isosceles. CBD is isosceles. It's isosceles triangle. That means we have angle CDB equals angle CBD. These two angles are the same. But on the other hand, the angle, because DC is parallel to AD, we have angle CDB equals angle DBA. So these three angles are all the same, And because CP is perpendicular to BD, so basically we have the following similar right triangle. Triangle CPD is similar to triangle ADB. Let me mark here CPD. The blue one is similar to triangle ADB because we have AD perpendicular to BD. Then we have the ratio DC over AB equals DP over BD. But DP over BD, that's 1/2 because P is the midpoint. So that means we have AB equals twice CD equals 86. Now we know the ratio is well known that triangle CDO is similar to triangle ABO. So DP to DO to OB, the ratio is equivalent to DC to AB, which is 1 to 2. That means OD is 1/3 of BD. So we can express OP. OP is DP minus OD. DP is 1/2 of BD. OD is 1/3 of BD. So OP is 1/6 of BD. This is given as 11, so we know BD equals 66. BD equals 66, AB equals 86. AD equals AB square minus BD square root. AB is 86 square minus BD equals 66 square. Let's simplify. We will get this equals 4 root 190. That means the answer m plus n equals 194. The answer is D. Question 18. F is a function defined on the set of positive rational numbers with property that f8 times b equals f8 plus fb for all rational number a and b. And suppose f p equals p for prime number p, which the following number x gives the value negative. So let's derive some property of the function. First, if we set a equals b, we will have a square, fa squared is fa plus fb, right? So similarly, we can say like a squared. This is f a times a. This is fa plus fa. This equals twice fa. So similarly, we can raise the power. So we have similarly f a to the k's power. This becomes f a k minus 1 times a. This becomes f a k minus 1 plus fa. So each time we can split this power. Finally, we will have this equals k times f of a. Next, let's plug in some special numbers. Say f1, because 1 times 1 is 1. f1 equals f1 times 1 equals f1 plus f1, which is 2f1. f1 equals 2f1. That means f1 must be equal to 0. Now, f1 for any number 1 equals a times 1 over a. Suppose a is positive rational number. And from here we have fa plus f of 1 over a. But this equal to 0 because f1 equals 0. That means fa equals negative f1 over a. So based on these relations, we can simplify each expression in the choices. Let's see, we have f17 over 32. So this is f17 plus f1 over 32. This equals 70 minus f of 32 because fa equals negative f of 1 over a. And f32 is 2/5. This is 17 minus 2 5 f2. And f2 equals 2. So it's 17 minus 5 times 2, which is 7. And 7 is a positive number. So we don't choose A. So B, f11, 16. Similarly, this equals f11 minus plus f1 over 16. But this can be equal to 11 is prime. So f11 equals 11. This minus f of 16. We find the reciprocal. 11 minus f2 to the 4th. This equals 11 minus 4 f of 2. f of 2 equals 2. So it's 11 minus 2, 4 times 2, which is 3. This is positive. Now f of 7 over 9 equals f of 7 plus f of 1 over 9, which is 7 minus f of 9. But 9 equals 3 squared, so 7 minus 2 times f3, which is 7 minus 2 times 3 equals 1. This is a positive. And we can also check okay, let me do it here, f7 over 6. This equals f7 minus, okay, we just, okay, plus f of 1 over 6. This is 7 minus f of 6. f of 6 is f of 2 plus f3. 2, 3 are prime numbers, so 7 minus f2 minus f3. That's 7 minus 2 and minus 3, so this is 2. This is positive. So the answer is E, and this is negative because, let's check here, f25 over 11. This is f25 plus f1 over 11. This is 25 is 5 squared. 11 here, we find the reciprocal is negative f of 11. This is 2 times f5 minus 11. So 2 times 5 minus 11. This is negative 1. This is negative. So the answer here is E. Question 19. The area of the region bounded by the following formula can be written as m plus n pi, where is m plus n. So here we need to find this region. In this formula, we have absolute value. So let's try to determine the sign. It could be positive, it could be negative. The boundary on the boundary is x minus y equals 0 and x plus y equals 0. That's the boundary lines. Now let's draw the coordinate system. And these two lines. So this is x minus y equals 0. This is x plus y equals 0. So these two lines divide the coordinate, the plane into 4 regions. So say this is region 1, this is region 2, this is region 3, this is region 4. So in each region, we can determine the sign for both absolute value. Let's consider region 1. In region 1, we have x minus y positive and x plus y also positive. So both are positive. Now the equation becomes x squared plus y squared equals 3x minus y plus 3x plus y, which equals 6x. And then we can complete square. This becomes x minus 6. Sorry, x squared minus 6x plus y squared equals 0. So basically we add a 9 on both sides and then we can complete square. So x minus 3 square equals 3 square. So this is a circle. The center of the circle is at 3, 0. The radius of the circle is 3. So let's draw this piece of the circle. It's basically a semicircle. Okay, this is a semicircle. And for other parts of the semicircle, it's not in this region. So we only have this piece. Similarly, we can discuss the region 2, 3, 4, and accordingly find the curve, the branch. And here we have a better way because this formula is very symmetric. If we change xy, if if I change x to y and y to x, the equation is the same. So y squared plus x squared equals 3, y minus x plus 3, y plus x. This is equivalent to the original formula. So that means our curve is symmetric along y equals x. Same. Same equation. That means the curve is symmetric with respect to the line y equals x. So that means we can simply draw the piece here. This is also a semicircle of radius 3. And it's also, we can also see that if we change x to a negative x, or if we change or y to negative y, the formula, the equation does not change. That means the curve is symmetric with respect to the x-axis and the y-axis. X-axis and the y-axis. So from here, we can just draw other branches of the curve. So this is also semicircle of radius 3. This is also semicircle of radius 3. So this is the complete curve. And we can find the total area. The total area is a square. The center part is the square. The side length is 6. So square part is 6 square plus the semicircle part. We have 4 pieces of semicircle, so there is basically 2 complete circle. Pi times 3 square. So it's 36 plus 18 pi, and we got MA. M plus N equals 36 plus 18. The answer is 54. So the answer here is E. Question 20. In how many ways can the sequence 1, 2, 3, 4, 5 be rearranged so that no 3 consecutive terms are increasing and no 3 consecutive terms are decreasing? Let's start from a number A. Suppose the next number is larger. Then the next number C should be smaller than B. Otherwise, we have 3 consecutive terms increasing. So C must be smaller than B. And the D, B, C, D cannot be decreasing. So D must be larger than C. So D must be here. And finally, E must be smaller than D. Or we start from A and the B is smaller than A. In this case, we should have C larger than B and the D smaller than C and E is larger than D. We have these 2 kinds of shape and these 2 are symmetric. That means each case has the same number of valid sequences. We can just flip, right? And so here, let's just consider the first case and multiply the number by 2. Now, in this case, the structure looks like a symmetric. So we just consider, let's compare the number B and the D. This is symmetric. Let's see, B is smaller than D. B is smaller than D. And the D is larger than B. So B is larger than A and C, D is larger than C and E. So it means D must be equal to 5. D must be 5. And for B, B is larger than at least two numbers. So B can be 3 or 4. There are two cases. So first case, D is 5 and B equals 4. So here we just put 1, 2, 3 in the bottom row, and any arrangement works. So we have 3 factorial equals 6. Second case, D equals 5 here. Suppose B equals 3. And then we must place 4 at the position of E. E must be 4 must be at E. That because 4 is smaller than 5 and larger than all other numbers. In this case, we just put 1 and 2 in any possible way. So 2 factorials, this equals 2. So totally we have 8. So here we have 8 cases. So this is for the case that B is smaller than D. Similarly, we can discuss D smaller than B. We also have 8 cases because it's symmetric. So totally our answer will be 8 plus 8 and times 2 because we also have 8 plus 8 here. So 8 plus 8 times 2, the answer is 32. We have 32 valid sequences. Question 21. ABCDEF is a equiangular hexagon. Let me sketch equiangular hexagon. That means each angle is 120 degrees. So this is 120, 120, 120. Let me call A, B, C, D, E, F. Now, the line AB, C, D, E, F determines triangle's area given. So we extend AB, C, D, and E, F. Let's draw this triangle. This is an equilateral triangle because each angle equals 60 degrees. Right? Because we have 120 here, so two angles are 60 degrees. 60 degrees. So each part is equilateral triangle. We have this angle 60 degrees. So similarly, this is 60 degrees. 60 degrees. So this is an equilateral triangle. Now let's discuss let's consider the side lengths of this equilateral triangle. This let me call this side length to be A. The area is given by √3/4 A squared. That's the area formula for equilateral triangle. It's given as 192√3. So this means that we have A equals 16√3. The side length is 16√3. Here we assume AB equals A, BC equals B, CD equals C, DE equals D, EF equals E, FA equals F. 6 sides. We have that. We can express the side length A in 3 different ways. On the top, this equals F plus A plus B. F plus A plus B equals 16√3. And on the right, this is B plus C plus D. This is side length 16√3. And on the left, we have D plus E plus F. D plus E plus F. This is also 16√3. So we got these 3 equations. And next, we consider the other way to find an equilateral triangle. We extend BC, DE, and the FA. If we extend BC, DE, and FA, we get another equilateral triangle. The argument is similar. This is an equilateral triangle. Let me call this side length to be B. So we have the area formula. The area is given by 324 root 3. From here, we can solve B equals 36. Again, we can write the side length in 3 different ways here. First, we have on the right, that equals A plus B plus C equals 36. And then on the bottom, we have a C plus D plus E equals 36. On the left, we have E plus F plus A equals 36. So totally we have this 6 equations. 1, 2, 3, 4, 5, 6. So our last step is to add all these equations. 1 plus 2 plus 3 plus 4 plus 5 plus 6. And we find that each side appears 3 times. So for example, A appears 3 times. In the first system, it appears once. In the second system, it appears twice. And see, for example, B, in the first system, it appears twice. In the second system, it appears once. So for each side, it appears 3 times. So totally, we have 3 times A plus B plus C plus D plus E plus F. On the right, this equals 16 root 3 times 3 plus 36 times 3. And then we can just divide by 3 on both sides. A plus B plus C plus D plus E plus F equals 16 root 3 plus 36. And that's the parameter. That's the parameter. And now we can find the M and P. M plus N plus P is 36 plus 16 plus 3. This is 55. The answer here is 55. Question 22. So here we have a note, algebra notes with 25 sheets and totally 50 pages. Some consecutive sheets are removed, borrowed, right? And the remaining part has the mean to be 19. And we need to find how many sheets were borrowed. So the removed parts are a consecutive set of sheets. All right, let's find the structure of this notes. Let's see, sheets. We have totally 25 sheets. Let me write this one: the first sheet, the second sheet, the third sheet, up to the 25th sheet. Each sheet has 2 pages. So the first sheet corresponds to 1 and 2 in pages. See, pages. Second sheet corresponds to 3 and 4. Last sheet corresponds to 49 and 50, the page numbers. And now we remove some sheets. Let's see the removed or the borrowed sheets. Suppose we borrow the sheets like from K sheets, K plus 1 sheets, and the K plus P minus 1 sheets. That means we borrow P sheets. We need to find the P, the number of sheets borrowed. So here, K sheet number is 2K minus 1, and the 2K, that's from the K sheets. K plus 1 sheet is 2K plus 1, 2K plus 2. The last sheets have the pages 2K plus 2P minus 3. and 2k plus 2p minus 2. Those are borrowed page numbers. So here we count the sum of all page numbers. Okay, the sum of all page numbers. This is like 1 plus 2 plus 3 plus 50. That's the sum of total number. This equals 51 times 50 divided by 2, which is 51 times 25. And next, we calculate the sum in a different way because we divided those into two parts, the borrowed one and the unborrowed one, the remaining parts. For the borrowed part, for the borrowed part, we just calculate the sum 2k minus 1 plus 2k all the way up to 2k plus 2p minus 2. The numbers borrowed, the numbers in the borrowed sheets has a sum equals this formula, okay? This equals 4k plus 2p minus 3. We have totally 2p pages, okay? P sheets, but 2p pages times 2p and divide by 2. This is the sum of the numbers borrowed. And they are remaining part. Remaining part. For the remaining part, we know the mean value. So we have totally 50 minus 2p numbers pages remained, and the average is 19. Okay, and then we have the equation as follows. The sum 51 times 25 equals p times 4k plus 2p minus 3 plus 50 minus 2p times 19. Both sides equals the sum of total numbers. And we can mode constant to the left. Here the constant is 50 times 19. So 51 times 25 minus 50 times 19. This equals p times 4k plus 2p plus 3. So here we have 38 minus 38p. So minus 38. This means we have the following equation. This equals 25 times 13. Basically 51 minus 38. So 13 equals p times 4k plus 2p minus 41. We got this equation on p and on k. What we want is the p. And here p is a number between 1 and 25. So first we note that p. So here from here we see that so p could be, say, p, the candidate number for p could be is larger than 1. So if, for example, it's 5, 13, so it cannot be 25. So the only possible number is 5. But 5 does not work. P equals 5. If we borrow 5 pages, we can basically 5 sheets. We can basically remove the last 5 sheets. That's the minimum mean. If we remove the last 5 sheets, we get a minimum mean. That's 1, 2, 3, up to 40. Okay, So this gives the minimum mean equals 40 plus 1 divided by 2. This is larger than 19. Okay, larger than 19. In here, we have the remaining part with mean equals 19. So P cannot be 5. If we don't remove the last 5 sheets, the mean is even larger. So this is impossible. And then we have a P equals 13. So P can only be 13. And here we can solve K. You can plug in and solve K equals 10. So the answer to this question is P equals 13. Question 23. We have 3 by 3 grid. And the frog start to hop from the center square. Let me call the center square to be A. And it can choose, each time it can choose one direction, up, down, left, right, and with equal probability. So each one is 1/4. And if it's at a boundary, you can keep jumping to the next one. For example, if it's at the top, you can keep jumping upwards, but that means jump back to the bottom square. Similarly, on the right, on the right, you can keep jumping to the right, and they jump back to the left. Okay, because it wraps around in the jumping. So let's discuss different cases in the jumping. Okay, so let me call the center square to be A, and I will see there are only 3 types of squares. One is the center one. The other one is this 4B. Okay, this 4B. They have the similar role. They are on either on the bottom row, bottom column, the middle square. And the third kind of square is the corner. We have 4 corner square. Whenever the frog jumps to the corner square, it stops there. It should stop there. Now let's see. The question here is if the frog jumps, hops at most 4 times. The frog makes at most 4 hops at random. What's the probability she reaches a corner square on one of these hops? Right. Let's check the probability of jumping from one square to another square. Say we have the following probability. If we start from A, it can only jump to B because we only have neighbor square, B square. So let me call it jumping from A to B. This probability is 1. That's for sure. And then we can have probability from B. If we start from B, we can go to C. If we start at B, we can go to C. And the probability is 1/2. 1/2. Because the other 2 directions are A and B. Only 2 directions provide C. Similarly, we have from B, we can also jump back to A. From B to A, the probability is 1/4. Only one direction has A. From B, we can also jump to B because the jumps wraps around. We can jump from B to B. This has probability 1/4. Okay. Now let's see. If we start from A and reach C within 4 hops. Let's see A here. From A, the first hop can only arrive at B. There's no other choice. And then we see from B, there are more choices. From B, we can hop back to A or to B or to C. So from B, we can hop to any square here. Let me call A here. From B, we can go to A. We can go to B. We can go to C. There are 3 cases. Now, if we go to A, if it goes to A, we will see that the next hop can only be B. Once you start hop from A, the next square must be B. And remember, we have at most 4 hops. In order to reach C from B, we must go to C. That's the first case. And now let's consider the second case, B to B. From here, B to B, we have 3 cases. B to A, B to B, and B to C. So at here, we already have three jumps. The last case provided the conclusion here. We can stay at the C here. If for A, in order to get to C, there's no way, because from A the next step we can only go to B. So this case does not provide any possible way to reach C within 4 steps. And then from B, so we only have the last hop, so we just hop to C. This works. Now let's consider the last case, A, B, C, and this is already done. So from this structure, we see there are four cases to provide the possible paths. 1, 2, 3, 4, and let's add all this probability. P1. For P1, that's P A to B times P B to A times P A to B times P B to C. This is 1 times, so B to A, the probability is 1 over 4. A to B is 1. B to C, the probability is 1 over 2. So this number is 1 over 8. And the P2, P A to B, P B to B, P again B to B. And then finally we have P B to C. So P A to B is 1. B to B, that's 1 over 4. B to B, 1 over 4. B to C, we have 1 over 2. This is a 1 over 32. And then let's see P3. P3 is PA to B, P B to B, P B to C. This is 1 times 1 over 4 times 1 over 2. This is 1 over 8. And finally, we have P4 is PA to B, PB to C. This is very short. PA to B is 1, PB to C, that's simply 1/2. So okay, we just add these numbers. That's the total probability. So answer here is 1 over 8 plus 1 over 32, 1 over 8 plus 1 over 2. The answer is 25 over 32. We choose D here. Question 24. Here we have 2 equations. They bound a quadrilateral. And we see that for both equations, we can take square root. So basically, they are 4 straight lines. Now let's find these 4 lines. The first line is here. We take a square root. Let's take a square root. We have x plus ay equals positive or negative 2a. we have two straight lines. They are parallel. They have the same slope. And the other one is ax minus y equals positive or negative a. Okay, so let's check the slope. For the first one is y equals minus 1 over a x plus or minus 2. From the second equation, we have y equals ax, say minus or plus a. Well, minus or plus a, right? We can still write the plus or minus a. Now, we see the slopes. The slope is, the first slope is negative 1 over a. The second slope is a. So the product equals minus 1. That means the slope from first groups and the slope from second group, they are perpendicular. Okay, so we draw some curve here. Let me draw a system. This is x, this is y. For the first two curves, the slope is negative because we are consider a is positive, so the slope is negative. So basically, we have a line something like this. This y-intercept is 2. The other one with y-intercept negative 2. This is negative 2. This is the first two lines. And the second, we consider the other, the second two lines. So slope is positive, which is a plus a or minus a. So they are perpendicular. Suppose this is a. This is a. This is negative a. Okay. So this is the basic picture for this four lines, and the quadrilateral here turns out to be a rectangle. So the question here is to express the area of the rectangle in terms of a, in terms of a. Now, in order to find the area of a rectangle, we need the length and the width. Let me sketch again here and mark the length and the width. Suppose this is the length. Okay, here's the length. Suppose this is the width. And we notice that because it's very symmetric, the center of the rectangle is the origin. Centers at O. This is the center at O. Here we can use the distance from a point to a line to find the length and the width. For example, the distance from the center to this line, this distance is 1/2 of the width. 1/2 of the width. This is the distance from the origin to the line with positive slope ax minus y. So accordingly, we have ax minus a, ax minus y minus a equal to 0. Okay, and we have a standard formula to find the distance, right? So if we have a line, this is ax plus b y plus c equals 0, and we have arbitrary point x naught, y naught. The distance have a standard formula. So p, the distance from p to the line L this equals ax0 plus by0 plus c absolute value divided by square root a squared plus b squared. Let's apply the formula here. So here we have x, y, x naught, y naught both equal 0 because the point is the origin. So basically we have absolute minus a root a squared plus 1. That means we have the width equals 2a, because a is positive, root a squared plus 1. And next, let's find the length, the L. The L is the other direction from origin to the line here. One half of the length is the distance from the origin to the other line. Here, this line is y equals minus 1 over ax minus 2. So y equals minus 1 over ax minus 2. That's equivalent to, this is equivalent to minus x. Okay. Let me move to one side to the standard formula. So it's x plus ay plus 2a equals 0, right? That's equivalent. And the formula gives the following. Is 2a absolute value is equal to just 2a, 1 plus a square root. So we have L equals 4a over root a squared plus 1. Now we can finally express the area. Area equals the length times the width. That gives 8a squared over a squared plus 1. And the answer here is D. Question 25. We have a 3 by 3 grid. And 3 red chips, 3 blue chips, 3 green chips. They are indistinguishable. And we place these 9 chips to these 9 boxes in order that no 2 chips of the same color are directly adjacent to each other, either vertically or horizontally. So same color chips cannot be next to each other, horizontally or vertically. How many ways can we do that? So here, a very special box is the center box. So let's consider the center square. Well, it could be any color, right? It could be any color, like the red color. It could be green color. It could be blue color. It could be any chip on the center. And there must be one chip from these 3 colors. We can simply discuss one color and then multiply by 3 because the cases are symmetric. Just place R and then we get a number, and we will multiply the number by 3. Just place. The other 2 cases are similar. Okay. So suppose the center part is R. Now let's see how many ways can we have this. Can we put the other chips to satisfy the requirement? Because R, we have 2 more R's. 2 more R's. And these 3 R's cannot be next to each other. So that means the other R's must be from the corner, must be on the corner. You see, this is center part is R. And there are many ways to place two R's on the corner. The other two R's must be at corner squares. And these two R's may be on opposite corners or on adjacent corners. So we suppose in the first category, we have the other R in adjacent corners. Of course, this could be, there are four cases, right? The bottom adjacent corner, the right column adjacent corner, the top adjacent corner, and the left adjacent corner. Here, I just draw one picture. So finally, we should multiply this by 4. The other cases R is on opposite corners. There are basically two cases, either this picture or the other diagonal line. Okay, let's discuss the first case. The R, suppose R is on the bottom corner. The bottom corners, they are adjacent. Now we need to consider the other two colors, blue and the green. Suppose we consider the top middle square. This could be blue or green. Suppose it's blue, and the other two blues cannot be adjacent to this blue, so we can have B this way or B this way. But this B does not work because we have the other two box adjacent. They must be, both of them be green. This is invalid. They cannot be next to each other. So that means we only have one way to place other two blues. That is blue in this way. And accordingly, green should be the remaining squares here. Of course, we can switch the role of B and G. For example, we can have a G here, G here, G here, and blue here, and the blue here. So they are basically two ways to place B and G. So in this case, we have four cases. Sorry, 2 cases. Let's see, 2 solutions. And we remember this R could be on the bottom corner, could be on the right adjacent corner, on top adjacent corner, or left adjacent corner. There are 4 cases to place these 2 R's. So totally we have 2 times 4. So here, I mean, the other 2 R's, in the first case, R is on the adjacent corner. Let me see. Corners. So there are 4 cases. For each case, we have 2 solutions here. So totally we have 8 cases, which is 4 times 2. So this is the case that the other 2 R's are adjacent. And next, we consider the case that the other 2 R's are on the opposite corners. opposite corners. And there are two cases because we have two diagonal lines. Now for each case, let's see how many ways can we place B and G. Let's take this picture here. So we have let's check this corner. Let's check this our left up corner. Suppose this is B. It can be B or it can be G. Suppose it's B. Suppose this is a B. We have another 2B must be on the right lower right corner. There are three. We must make sure we don't have adjacent corner remained because we need to place G, right? So B must be placed in this way. And accordingly, we have green, green here, and a green here. Or we can switch the role of B and G. G here, G here, G here, and the blue here. Blue here. So in this case, totally we have that there are two ways, two solutions. And then we have 2 case times 2 solutions of 4. So now we discussed all possible cases that when the center square is R. And we can also place G and B on the center. So totally we have 3 times 8 plus 4. The answer is 36. There are totally 36 ways to place all the chips. Okay, that's all solution to this test. Thank you for watching.